Here's the next question, number 35. The Z parameters of the two-port network shown in the figure are Z11 is equal to 40 ohms, Z12 is 60 ohms, Z21 is 80 ohms, and Z22 is 100 ohms. The average power delivered to RL is equal to 20 ohms in watts is dash. Okay, so this is again not a multiple choice question. Let's work it out. Alright, so to begin with, we'll write down what's been given to us. We have the Z parameters given. The values of Z11 is 40, Z12 is 60, Z21 is 80, Z22 is 100. So these are the Z parameters given. Now let's look at the figure here. We can write down equations for V2 and V1. That's what we must do. So let's look at V2 first. Now V2 is equal to, let me just write that, V2 from the figure, V2 equals minus I2 RL. Look at the direction of the current. That's important. Okay, so here we have minus I2 into RL, which is minus 20 I2. That's because the value given for RL is 20. So minus 20 I2. Let's call this equation 1. Now let's write down the equation for V1 in terms of the Z parameters. Now you're quite familiar with how to do this. We write this as V1 V2 is equal to Z11 Z12 Z21 Z22 into I1 and I2. This is how we write the matrices in terms of the voltages, the Z parameters and the current given to us. Now from this, let's write down our two equations. Our two equations would be V1 is equal to Z11 I1, we are multiplying, okay, plus Z12 I2, V2 would be Z21 I1 plus Z22 I2. So these are our two equations. Now we have the values of Z, the Z parameters given to us. Okay, so let's substitute that, and we also have V2 in terms of I2, minus 20 I2. Okay, so let's start with this. Let me just take another sheet of paper. Right. Okay, so we have the equation V1, Z11 I1 plus Z12 I2. We'll substitute the values. We get V1 is equal to 40 I1 plus 60 I2. Let's call this equation 2. Next, we have V2. V2 is equal to Z21 I1 plus Z22 I2. We have our values for Z21 and Z22. Let's substitute, including the value for V2. V2 is the expression from equation 1, which was minus 20 I2. So that's minus 20 I2 is equal to 80 I1 plus 100 I2. Let's call this equation 3. Now if we simplify this even further, we'll get a relation of I2 and I1 in terms of each other. So that's minus 120 I2 is equal to 80 I1. I2 is equal to minus 80 by 120 into I1. We can simplify that and write it as minus 2 by 3 I1. So I2 is equal to minus 2 by 3 I1. Let's substitute this into equation 2. Let's substitute that into equation 2. So what will we get? We'll get V1 is equal to 40I1 plus 60I2, right? So in terms into I2, let's plug this in. We'll get 40I1 plus 60 into minus 2 by 3 I1. So this results in 40I1 minus 40I1, which is 0. So this means that the value of V1 is 0. Now let's go back to the figure and look at just this loop over here. Just this loop. We have I1 here. So in this loop we can write our voltage equation 20 plus 10I1 plus V1. Let me write that down. Right. Okay. So from the first loop, I'll write that from the figure, this is for loop 1, the first side of the loop. We can write down the voltage equation, and the voltage equation is 20, that's the source, is equal to 10I1, that's the voltage across the resistance, plus V1. Now we know the value of V1, we just found it to be 0. So let's substitute that and solve. 20 is equal to 10I1 plus 0, which gives us the value of I1 to be 20 by 10, which is 2 amps. Now that we have the value of I1, we can easily find the value of I2. I2 is equal to minus 2 by 3 I1. That's the relation that we found here. Minus 2 by 3 I1. So let's substitute. Minus 2 by 3 into 2, which gives us minus 4 by 3 amps. Now the question talks about the power dissipated. Now the power dissipated to here. See, the power delivered. The power delivered to the resistance, the load resistance of RL. So the power equation is VI. So the voltage and the current across that resistance is what we need. And we see from the figure that the voltage is V2 and the current is I2. So that is what we need. We need V2 and we need I2. We have our I2 here. We also have the relation of V2. Right, so in fact, we don't need V2. Let's just use RL instead. You can use any power formula, whatever comes to your mind, really. So we know the power formula is VI. We also know that it is I square R, and we also know that it is V square by R. So either one, any one of these you can use. It's not a problem. So in this case, let's use I square R. So we have the power to be I square is I2 because that's the current that is passing through the resistance, the load resistance. So that's minus 4 by 3 whole square into R, which is 20. So solving this, we get 16 by 9 times 20. 35.55 watts. So this is our final answer. The power delivered to the load resistance is 35.55. Here, 35.55. So this is the entire solution, and I hope it has helped.